Okay, here we go. So before we get into doing some other types of problems, I want to just sort of introduce the idea of bases other than base 10. We looked at number systems that were a little unique on Monday when we did clock arithmetic and modular arithmetic. It wasn't just 1 through 10 all the time. There was more to it than that. And that's what we're going to look at today. My question to you, the first question here is, what is the largest three-digit number in base 10? The system we use, what's the biggest three-digit number that we could have? It's not a trick question, I promise. What's the biggest three-digit number we can have? All right, very good. Yes, Christopher, Will, Madison, you can be confident in that answer. It is correct. Basically, a three-digit number, we'll put the highest digit we could possibly put there. And so 999 would be the biggest three-digit number we'd have in our base 10 system. Keeping in mind that in base 10, the digits that we have to work with are 0 and then 1 through 9. Base 10 system, the biggest digit is 9. If we put that biggest digit in each position, then we have the biggest three-digit number. With that in mind, and now we're taking a little bit of a step forward, keeping the pattern in mind, what would the largest three-digit number be in base 6? Very good, Joanne. Great, Will. Yes, Madison, you're exactly right. That's awesome. Very good. And it might be helpful here to think, well, in base 6, that would mean our numbers would be 0, 1, 2, 3, 4, and 5. In a base 6 system, there are going to be 6 digits, 6 numbers that we can work with. 0, 1, 2, 3, 4, 5. Just like in base 10, the largest digit is 9. If we're working in base 6, the largest digit we can possibly have is a 5. And so if we want to write the largest three-digit number in base 6, it's 555. Hopefully that's at least understandable, even if it's not completely comfortable quite yet. All right, let's talk about base 6 a little bit. And I just kind of listed out that the digits that we have to work with are 0, 1, 2, 3, 4, and 5. There'd be 6 of them. And those are all the digits we have in this system. There is no 6, there is no 7, there is no 8. Those don't exist. We just have 0, 1, 2, 3, 4, 5. Let's look at our place value positions. Thinking back to how we figured out what ones, tens, hundreds, and thousands would be, if we want to figure out our place value positions in base 6, we're going to have 6 to the 0 power. That's going to be a ones column. When we move over one spot, that's going to be 6 to the first. Sixes. So we're going to have a ones column. We're going to have a sixes column. We'll have 6 squared. 6 times 6 is 36s. And then if we keep going, we'd have 6 to the third, which is, let me just pop that in here real quick, 216s. So if we're working in base 6, we don't have ones, tens, and hundreds. Instead, what we'll have is ones, sixes, 36s, and then 2 16s. And we could have 6 to the fourth if we kept going, but this is probably far enough. With that in mind, when we wrote the largest three-digit number in base 6 and came up with this right here, when we're in base 6, and one way to indicate that is to put a little 6 next to it. Another way is to just put base 6 next to it. Either of those is, so you can write the 6 as a subscript, or you can just put base 6 in parentheses. A key here, and it's just me being a little bit picky, but I also want to make sure you understand what we're doing. Since our place value positions are not ones, tens, and hundreds, They are 1s, 6s, 36s, 216s. When we look at this number, we are not going to say 555 because it's not 555. This is 555 base 6. We're not going to call it 555 because those aren't hundreds. They're not tens. They are ones, but they're not hundreds and tens. So we're not going to say 555. Really, what that number would be, 555 base 6. And this goes back to expanded form from last week. It would be 5 36s plus 5 6s plus 5 1s. That's what the value of that number would be. Now, we're going to spend a lot more time doing that kind of thing next week, going back and forth between base 10 and other bases. But right now, I just want you to see how this is not 555 base 6. It's just 555 base 6 because those aren't ones, tens, and hundreds. So if I was going to start writing down numbers in base 10, and I was just going to go from small to large, and I'm just going to write down base 10 numbers. I would go 1, 2, 3, 4, 5, 6, 7, 8, 9. I've hit the end of the line. Next would be 10. I'm guessing you're all pretty comfortable with that. And I want you to notice what we've done here. The ones digit has gone to 0, and the digit next to it had to bump up by 1. That's how we got past the number 9. I want you to keep that in mind as we look at doing this with base 6. In base 6, if I start writing numbers down, I'm going to have 1, 2, 3, 4, 5, and I'm not going to have 6 next because I'm not allowed to have 6 in base 6. What is it that's going to go here? And I don't think that's an easy question, but I want to see how you do with it. Outstanding, Stephen. And if everybody's like, how in the heck did he get 10? Well, remember, it's not 10. It's 1, 0. Because we don't have a 6. We can't put a 6. So our ones digit goes to a 0, and the digit next to it bumps up by 1. And then we could have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. And what's going to be next? It's not going to be 1, 6. What's going to be next over there after we get to that one? Outstanding, Christopher Will, perfect. You're exactly right. This ones place is going to have to go to 0, and this place value is going to bump up by 1. Very good, Lee. Yeah, excellent. That's great that you're seeing that. Okay, and that's just base 6, but the other bases are going to work in a similar manner. Does anybody have any questions on what we just did there with counting our numbers in base 6? And as we went through them, we had, and there would be a 0, 1, 2, 3, 4, 5, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 0. Does anybody have questions how we got those? The reason we can't have a 6 right here is because 6 does not exist in this system. And the reason we can't have 1, 6 over here is because 6 doesn't exist in that system. All right, very good. This whole idea might feel pretty uncomfortable at first. You've worked your whole lives right here in base 10. There are 2 reasons for this. Part of it is that it puts you in the position of a kid who's never seen this before and learning it for the first time. You may have never seen base 6 before. So you're learning about how to count these numbers, what numbers do we have, what happens when we run out. So it's to put you in their position as part of the reason we study this. It's to give you a really good understanding of the base 10 system by working in these other bases. Okay, what comes after? It's the first type of question we're going to look at today. And if we're given the number 5, 9, base 10, well, it's base 10, so that's 59. That's no big deal. I know what 59 is, base 10. What comes after 59 base 10? Well, that's just 60. And that's because we've reached the last possible digit we have, so that becomes a 0, and we bump the next place value over up by 1, and that's how we get 60 as the next number. Let me know if you have any questions on that one. Probably not, but I'm going to give you a few of these to try. We're going to do a lot of relatively short polls today where it's what comes after. Well, let's try some. So if we're working in the base 5 system, what comes after 3, 4? I'll make a poll for this and let you try it. And we're going to do quite a few of these where these are questions you can expect to see. And we'll just do some practice. They may be a little bit challenging and difficult at first. That's okay. This is the kind of thing that the more you practice, the easier it gets. And it's basically about starting out a little uncomfortable, like, gosh, I don't really know. And then it gets more comfortable as we keep going. So in a base 5 system, what comes after 3, 4? We'll go another 20 seconds, and then we'll talk about this one. If it helps you to write out a series of numbers for these, that's okay. That's a really good question, Stephen. One of the really commonly used number systems, it's definitely useful in computer systems, is hexadecimal, and that's base 16. And part of the reason for that is because it's a power of 2, and ones and zeros are so important in computers, but instead of base 2, base 16 gets used. I'm not really sure how they settled on 16, but hexadecimal would be base 16. So in theory, Stephen, you could keep going higher and higher. For the most part, we live in our class, we're going to live base 10 and lower. We won't even look at hexadecimal in here. I do that in my Math 104 class, though, because some of them go on to be to do computer science things, and so being exposed to hexadecimal has some value in there. All right, let's see how this one went. Okay, strong agreement, not unanimous, but definitely good strong agreement here. That's really good because generally I kind of expect this one to be a little rocky because this is a hard idea at first. But if we're writing down the numbers in base 5, and it may be helpful for you to say, well, in base 5, that means I have 0, 1, 2, 3, and 4. Those are all the digits I have. Like anything else wouldn't make sense because it doesn't exist in this system. So 0, 1, 2, 3, 4, that's it. Okay. Well, if I'm at 3, 4, then, and I want to go to the next number, I can't put 3, 5 because 5 doesn't exist. So that's no good. So here at 3, 4, and the ones digit is going to have to go to 0, which means the digit next to it is going to bump up by 1. So 4, 0, base 5 is what would be next. And that was widely the most common answer, which is outstanding because I do think these can be a little twisty at first. Any questions on that one before I have you do another one? And we'll do a few of these. All right, let's try another. What comes after 517, base 8? Something that can be really helpful for you is to write out the digits that exist in base 8 and then answer the question. So if you do find yourself having some trouble with this, well, what digits do I have available to me? And okay, now that I know that, we'll see what I want to do here. One of the things you can lean back into is that first example we did, what comes after 59 in base 10? And you could do it with a 3-digit number too. What comes after 159 would be a parallel here if you wanted to look at a 3-digit number. And like I said, these are definitely types of questions you can expect to see in your practice and on a quiz or an exam. And let's try to hash out any difficulties you might be having. Let's go another, let's say 20 seconds, and then we'll do this one together. All right, let's see how we did here. Not unanimous, but definitely some strong agreement there. That's a good thing. If when we work through this, if you're not really sure how we got where we got, make sure you ask about it. What comes after 517 base 8? It may be helpful for you to write down what the digits are in base 8. There will be 8 of them, and the highest will be 7. Just like in our base 10 system, there are 10 digits, and the biggest one is 9. In the base 8 system, there are 8 digits, the biggest one is 7. So I can't have anything bigger than 7. So if I wanted to say what was next, my first thought might be, well, 518. Well, wait a minute. Can't have 8. 8 doesn't even exist in this system, so I can't write an 8. Okay, then how do I deal with it when I need to go up 1? Well, I want this to get bigger by 1, but there isn't anything I can do there. I can't make that an 8, so that has to go to 0, which means this has to increase by 1. One place value over has to increase by 1 and become a 2. And that's all I need to do to get to the next number. I don't need to increase the 5 because we're not going 3 place value positions over. All we needed to do is increase that 1 place value position and end up with 520. And if we wanted to be formal about it, we'd put a little 8 down there for base 8. Are there questions about how we got to 520? All right. In my notes, I was going to give you this before you worked on that one, but the first one went so well, I figured we'd try it without that, and you did great. Let's do another one. What number comes after 3, base 4? It may be helpful for you to say, hey, in base 4, we only have 0, 1, 2, and 3. That's it. So what's going to come next? Oh, yeah, good question, Alondra. Yeah, you would just put 520. You would not put the base 8 on the quizzes. You don't have a way of writing a subscript. And to have you type base 8 in parentheses opens up a whole other can of worms because do I put a space? Do I not put a space? Do I put a space in between the word base and the word 8? So it'll just be the 520. That's an excellent question. No problem, Austin. You're fine. We'll go another 20 seconds on this and then do it together. All right, let's see how we did. Oh, we're kind of split on this one. Okay, so we found one that would be challenging. Okay, here we go. Let's be patient and careful as we go through this one. So I'm at 3, 3, base 4, and I want to know what comes after that, what comes next. So I'm going along and I'm at 3, 2, 3, 3. I would love to write 3, 4, but wait a minute. Base 4 only has 0, 1, 2, and 3 in it. That's it. Those are the only possible numbers. There's nothing else, just 0, 1, 2, and 3. So it can't have 3, 4. That's no good. Okay, then. So as I'm doing this, then I want to increase this by 1. Well, it wraps back around and goes to 0. But then what about this one? Well, I guess I can make that a 4 and have 4. Well, no, wait a minute. That's no good. I can't have a 4. 4 doesn't exist in this system. So this has to bump up to 0 also. And then this place value that I don't even have yet has to go up by 1. And I end up with 1, 0, 0, base 4. Occasionally, I might slip up and say 100. You can call me out on it. But basically, it's if you do it, I understand. But the proper way to say that is 1, 0, 0, base 4. The parallel I want to show you for this one, because this one was the hardest that we had so far, and hopefully it makes sense now. The reason we can't do 4, 0 is because there is no 4 in this system, so we can't do 4, 0. But if we have the number 99 in base 10, and I want the next number up, well, 9 goes to a 0. This 9 needs to get increased by 1. It becomes a 0, and this thing that there isn't anything there yet becomes a 1. So if I went from 99 to the next number, I'd go to 100. It's essentially the same thing I've done here. In base 4, I've got the biggest number I possibly have in the ones place and in the place next to it. And so those go to 0, and then that place value that doesn't have anything in it yet has to get a 1. Let me know if you have any questions on that one now that we've been through it. Okay, very good. Now we're going to go the other direction. What comes before? Instead of what would the next number be, now we've got to go backwards. So instead of what would be next, it's what comes before 1, 0, base 4. Keeping in mind that base 4 only has those digits in it, I'm going to make a poll for you for this one. I think what comes befores are a little bit harder than what comes after. You may or may not agree with me. You may think they're both hard, or neither one of them's hard. They're fine. Or you might think, I kind of think that after what comes after is harder than these. If you want to try to find a parallel, pretend you're doing it in a base 10 system. What would it go to? And then think, okay, so the idea there, that's what has to happen with the numbers. I'm going to do the same thing with the numbers, but the only numbers I have to work with here are 0, 1, 2, and 3. That's it. We'll go another 20 seconds and then do this together. All right, let's see how we did here. Okay, really strong agreement on that one. Outstanding. That's very good. Very good. I think the what comes before are pretty hard. We just did really good on that one. All right, so let's see what we have here. We have 1, 0, base 4, and we want to know what comes before that. One thing you can do is kind of just pretend if I had 10 in the base 10 system, then this gets reduced down to a 0, and this goes to the top number in the system that I have. And that's how I go what comes before. So this 0 becomes whatever the highest number I have in my system, and that 1 gets reduced and becomes a 0. Same thing we're going to do here. This 0 becomes the highest number I have in my system. That's a 3. This 1 disappears because it was just a 1, so now it's gone. And so 3 base 4 is what we end up with for that one. Just 3. That's it. Just a little side note, because it was one of the choices. If this question had said what comes after 1, 0, base 4, then it would just be 1, 1. That would be the next number in the sequence. But this question said what comes before, and so since it said what comes before, we want our answer to be 3. I thought it might be. Yeah, that's why it was one of the choices, was making sure you're reading that carefully, because they're going to be what comes after questions. There's going to be what comes before questions. You want to make sure you're careful with looking at that. So now we have a 3-digit number, 540 in base 7. Just a little reminder. And you may not need this reminder, but there's our digits in base 7. If that's all we've got, what comes before 540? I'll make a poll for this one. One of the big things here is to recognize how the numbers feel a little weird, but other bases behave the same way as our base 10 system does. It just feels a little weird because the numbers are a little different. We'll go another 20 seconds and then do this one together. See how we did here. Almost unanimous. Very good. I think that's a tough question. Okay, outstanding. Maybe it's just a little bit of practice that's helping us out a lot. Maybe it's the what comes before aren't any more challenging than the what comes after. So what comes before 540 base 7? These are the only numbers we have to work with. So I'm at 540 base 7, and I want to know what comes before that. Well, what comes after would be 541, but I don't care about that in this one. I need this to go backwards by 1. I need it to go down by 1, and so it's going to go to the highest number I have in my system, which is a 6. This is going to have to go down by 1, and I'm at 536 base 7. Imagine if these give you trouble, if we had 540 in our base 10 system, well, you'd go 539, because this went to the highest number we have, and this went down by 1. And that's exactly the same thing we did over here to get 536 base 7. Let's try another one. What comes before 200 base 5? That last one went so well, I'm just going to let you do this one. You may want to think through what the digits would be in a base 5 system. That might help you answer the question. Some of you may be getting completely comfortable with this and not even need that step. That's okay too. Either way, it doesn't take very long to write down the digits that we have available in base 5. So if you write those down, that can be really helpful. Doing a parallel with a base 10 number can be helpful for you if you're finding these to be challenging. See what happens with a base 10 number, and then use that same philosophy with this base 5 number. Go another 20 seconds, and then we'll do it together. See how we did? Strong agreement, but we're spread around along every answer. Okay, so let's take a little time and talk through what's going on here. The main thing here that eliminates some of those answers for us is we're in a base 5 system. And what that means to us is that the only digits we have available are 0, 1, 2, 3, and 4. That's it. We don't have anything else. Those are the only possible choices. So anything that has 5, 6, 7, 8, 9 in it can't be right, because the only digits we have are 0, 1, 2, 3, 4. That's it. And then we're at 2, 0, 0, base 5. And I want to know what comes before that. Okay, well, what would come before that would be, this has to go backwards by 1. So that becomes my first thought is, well, then that becomes a 9. Wait a minute, it can't be a 9. I don't have 9. It becomes a 4, the biggest number I have in my system. I need to reduce this by 1, but I can't. It's a 0. So that has to go to the biggest number I have in my system. And now this one I actually can reduce by 1, and I end up with 144, base 5. If it helps to think about base 10 for a minute and say, if I'm at 200, what would be before that? 199 would. This went to the highest number I have in my system. I'd like to reduce this by 1, but I can't. So it goes to the highest number in my system. That one actually can reduce by 1. That's the approach we're taking here. We're just doing it with a smaller number system that only has 0, 1, 2, 3, 4 in it. Are there any questions about what comes after, what comes before questions before we move on to something different? And I do have good news for you. What we're going to cover next, if you find what comes after and what comes before to be helpful, what we're going to work on next will help you with those. Okay. Addition and in other bases. And before we talk about addition in other bases, I just want to do a little bit of a reminder of adding in base 10. If I want to add 56 plus 27 in base 10, our standard algorithm, which we'll spend more time talking about later in the term, but the standard way that we would add these numbers is we'd look in the ones column, and we would say, well, 6 plus 7 is 13. The problem is I can't put 13 there because 13 is not a digit in my base 10 system. So the way we handle this is, what do? There's a verb we'll use here to move something over there to the tens place. What's that verb? Carry, Laura. Yes. Yes. Well, yes and no, Katrina. You're not wrong, but that's me being fussy, and I haven't really talked about this yet. But actually, it's good that you brought that up. We are going to move the 1 over to the tens place. But when we move this 1 over, what we're actually carrying is 10. Because this has a value of 10 in this column. I put it over here as a 1 because it's in the 10s column. So what I've actually carried is a 10. Actually, I'm really glad you said it the way you did, Katrina. That reminded me to talk about it. So it's perfect. Thank you. And carry the 1 is perfectly normal language. You didn't do anything wrong there. I just, because we're so focused in on the base 10 system and place values, and I know what's coming next, I want to make sure to emphasize what we're carrying there is a 10. So we're carrying a 10 over. So instead of 13 here, we're going to reduce that by 10 and just leave a 3. And now we can add 1 plus 5 is 6 plus 2 is 8. And we end up with 83 for our answer. And what we did was we carried a 10. That's why this goes down by 10. And we put that in the 10s, 110 in the 10s column. Okay, so now let's turn this into something new. Let's look at 2, 3 base 4 added to 3, 1 base 4. So now I'm adding, but I'm adding base 4 numbers instead of base 10 numbers. So I'm going to look at my 1s column here, and I'm going to add those together. Now 3 and 1 is 4. And then 2 and 3 is 5. So 5, 4, base 4. Is that okay, or does anybody have a problem with that? There can't be a 4. Perfect, Laura, and perfect, Will. You're exactly right. 5, 4, base 4 is no good. Because in the base 4 system, the only digits I have are 0, 1, 2, and 3. That's it. I can't put a 4 there. You're exactly right, Katrina. So when I add 3 and 1 and get 4 down here, even that 4 is no good. So what I'm going to have to do is, because I'm working in base 4, I'm going to carry 4 over to the next place value position. So I'm going to carry 4. So this is going to get smaller by 4 and become a 0. I moved my 1 over to that column in the 4s column. And now I have 1, 2, 3, 4, 5, 6. Well, I can't have 6. That's no good. So I'm going to do it again. I'm going to carry a 4. When I carry a 4, this gets smaller by 4 and becomes a 2, and I move 1 over to the next column over, and now I can add that 1 down, and I end up with 1, 2, 0, base 4. A little strange. 2, 3, base 4 added to 3, 1, base 4 results in 1, 2, 0, base 4. The philosophy, though, is this. You will, Laura, you'll be fine. The philosophy is the same as what we did over here. We were working base 10, so we carried a 10. We're working in base 4, so we carry a 4. This gets smaller by 4, we put a 1 over there. This gets smaller by 4, we put a 1 over there. And that's how we add them. Let's try one. I want you to add 5, 3, base 6, plus 4, 5, base 6. I'll make a poll for this and let you try it. If this feels a little clumsy, that's normal. They get much easier relatively. Some things, it takes a lot of practice to get good at it. These, it just takes a little bit of practice to get comfortable. You'll notice the answers in the poll don't have base 6 written next to them. When you do this on a quiz or an exam, you wouldn't put the base 6 part. You'd just put the number that you ended up with. For a lot of students, these are quicker to pick up on than the what comes before and what comes after. Maybe that's true for you, maybe it's not, but carrying is something that's really comfortable. What comes before, what comes after isn't always comfortable. Takes a little adjustment to get used to the new number systems and realize, well, there's only 0, 1, 2, 3, 4, 5. That's it. That's the only things that are possible in this number system. We'll go another, I don't know, 15 seconds and then talk about it. If you want more time, let me know. If you get an answer that's not there, it's okay to pick the one closest to yours. All right, let's see how this one went. Not unanimous, but strong agreement. Okay, that's a good indicator. Let's see how this one goes. All right, so as I look at this and I want to add in base 6, so I'm in base 6, so that means my only digits are these. That's it, 0, 1, 2, 3, 4, 5. And I have 5, 3, base 6, added to 4, 5, base 6. Now, if I were in base 10, I'd just go 3 and 5 is 8, 5 and 4 is 9, and I'd be done. The problem is 9 and 8 aren't a part of this system, so I can't do that. Instead, I'll do 3 and 5 is 8, but I can't have 8. So what I need to do here, because it's a base 6 system, is I need to carry 6. So this is going to get smaller by 6, and I can put one over there in that column. And then 1 and 5 is 6 and 4 is 10, but I can't have a 10 there. It's a base 6 system, so I'm going to carry 6. This will get smaller by 6, and then I can add that and end up with 1, 4, 2, base 6. Now, the poll went really well, but if you have questions on anything that happened there, please make sure you ask. The key is when we carry, we're carrying 6 because we're in the base 6 system. All right, let's try another one. 4, 7, base 8, plus 5, 5, base 8. I'll do a poll for this one too. Tons of polls today because we don't have that many ideas to talk about. I just want to do a lot of practice so that it gets comfortable. Again, kind of question you can expect to see in your practice problems, on a quiz, on an exam, is just adding in other number bases. We'll go another 20 seconds and then do this one together. Let's see how we did here. Okay, strong agreement, but spread around a little. So let's be careful as we talk about it. If you see something that doesn't make sense or you're not sure of, please ask. There's no reason to have a unasked question. There's a really good chance somebody has the exact same question as you. So here we have 4, 7, base 8, added to 5, 5, base 8. We want to add those together. We're in base 8, which means our only digits are 0, 1, 2, 3, 4, 5, 6, and 7. That's it. Can't have anything but those. And so I'll go ahead and I'll add, and I'll have 7 and 5. Well, that would be 12, but I can't have 12 in base 8. If this were base 10, I'd leave the 2 behind and carry 10 over, but it's not base 10. This is base 8. So when I carry, I'm going to carry 8. This will get smaller by 8, and we'll put a 1 over there. That's where that 8 went. Okay, and then 1 and 4 is 5 and 5. That would be 10, but I can't have 10. Here again, when I carry, I'm going to carry 8. So that's going to go down by 8. Put a 1 over there, and now I can add those in that column. It's just the 1. And I have with 1, 2, 4, base 8. If there's anything in there that's unclear, didn't make sense, you let me know. It's important to remember when you're doing these that it's not base 10, it's not base 10, it's not base 10. And as long as you keep reminding yourself of that, you'll probably be all right. Okay. You probably knew this was coming. Subtraction in other bases. Before we do something in a different base, let's look at base 10. If I want to do 72 minus 38, our standard approach to subtraction is to look in the ones column and say 2 minus 8. Well, I can't do 2 minus 8. So what am I going to have to do here? When it was addition, we had to carry. What are we doing now? Borrow. And you're exactly right, Katrina. Great language. We are going to borrow 10. You're exactly right. So when I borrow, this is going to go down by 1 over there in the tens place. So I borrowed a 10. And so this becomes 12 over here because I borrowed 10. So it has to get bigger by 10. And now I can subtract. 12 minus 8 is 4. 6 minus 3 is 3. And I end up with 34 as my base 10 answer. Okay, so let's see what this looks like if we're working in a different base, like 4, 1 base 5 minus 2, 3 base 5. Okay, so I'm working in base 5 system. So the only numbers I have are 0, 1, 2, 3, and 4. That's it. That's all I've got. And I need to figure out how to subtract these. Well, okay, the normal approach for subtraction is just look in the ones. 1 minus 3. Well, I can't do 1 minus 3. So I'm going to have to borrow. The kicker is I'm not going to borrow 10. I'm going to borrow 5 because I'm working in base 5. When I was working in base 10, I borrowed 10. Now I'm working in base 5, so I'm going to borrow 5. This is going to get smaller by 1. This is going to go up by 5. Okay, and then 6 minus 3 is 3. 3 minus 2 is 1, and we're good right there with 1, 3, base 5. Let me know if you have questions on what we did there before I have you try one. Okay. 311 base 6 minus 124 base 6. I'll make a poll for this and let you try it. It's 3 digits, so it's a little more complicated than the last one, but my sense is that many of you are really getting the hang of this working in other bases thing. So we'll try stretching a little bit on this one. Keeping in mind that we're in base 6. That has a whole lot of implications in a problem like this. It means a whole bunch of things. It means we only have a certain number of digits that we can actually work with. And when we go to do our subtraction, the fact that we're in base 6 plays an important role in that. We can go another, I don't know, maybe 25 seconds on this one, and then we'll do it together. If you need more time, let me know. If you get an answer that's not there, pick the one that's closest to yours. All right, let's see how this one went. Oh, agreement, but kind of split between two different answers. All right, so let's take a look here. You make sure and ask whatever questions you might have. So as I go to work on this one, what we're looking at here is 3, 1, 1, base 6 minus 1, 2, 4, base 6. Base 6 tells me that I'm only going to have 0, 1, 2, 3, 4, and 5 as possible digits. And it also means when I have to borrow, I'm going to borrow 6. Okay, with that in mind, start in the ones place, 1 minus 4. Well, I can't do that. I can't do 1 minus 4, so I'm going to have to borrow. So this is going to become a 0, and this is going to get bigger by 6 because it's bigger by 6 because it's base 6. I borrowed 6, so that becomes a 7. It gets bigger by 6 because I borrowed 6. Okay. Okay, now I can subtract in the ones. That's 7 minus 4 is 3. And now I move over to the next place value over, and I'd like to do 0 minus 2. The problem is I can't. 0 minus 2 I can't do. So I'm going to have to borrow again. I'm going to have to borrow from here, and this is going to get bigger by 6 because it's base 6. And now I have 6 minus 2 is 4, 2 minus 1 is 1, and I end up with too many colors, but 1, 4, 3, base 6. Basically, we had to borrow twice, which is the same thing we would have to do in base 10. If we wanted to do 311 minus 124, I would, 1 minus 4 I can't do, so this gets smaller. This becomes 11, I can subtract. I can't do 0 minus 2, so this goes down by 1, this goes up by 10. 10 minus 2 is 8, and I get 187. The process is exactly the same, and that is why we study it, is to emphasize what it is we're doing when we're doing all of this by looking at it in something that might be new and different for you. Because we're in base 6, we borrow 6. Are there any questions on what we did in that one? The fact that we had to borrow twice made it more challenging. Okay, one thing I want to mention before we put addition and subtraction and other bases behind us is looking back at this addition problem that we had in base 8, we carried 8. I mentioned that if you thought that the what comes after questions were a little challenging, there's a way you can approach that. Let's say, we'll just stay in base 8 since we're on this page, but let's say you had 7, 7, base 8, and you wanted to know what comes after. One way is for you to just say, well, I'm at the end of the line, so this has to become a 0, and that has to go up by 1, and it's, oh, actually in base 8, it would have to be that way, but I didn't want it to be like that. Let me maybe make it different. Let me make it 30 or 3, 7, base 8. I got myself twisted. Let's make it 3, 7, base 8. Oh, hang on a second. 3, 7, base 8. And I want to know what comes next. And the 7, that's the end of the line, that has to become a 0, so this has to go up by 1 and become a 4. Another approach you can take with those, if you liked adding in other bases, when you get a question that is what comes after, you can just, if this is 3, 7, base 8, I'm going to add 1 to it. 7 and 1 would make an 8, but I can't have an 8. Since I'm in base 8, I'm going to carry 8. This goes to 0, and a 4 comes down when I add those two. So if what comes after was hard for you, but the adding was comfortable, if it says what comes after, all you need to do is add 1, and your result will be what comes after. Sorry, that was so clumsy. My screen went goofy. My example was too hard at the beginning, but I hope that makes sense of it. The idea that If you want to know what comes after, and those are hard, but the addition was comfortable, just add 1. And then what you get is what comes after. As you would expect, the same thing is true for subtraction. If what comes before is hard for you, and this page was base 6, so let's say we have 2, 5, or 2, 0, base 6, and we want to know what comes before. Some of you can say, well, that's a 0, so I've got to go to the biggest number I have and reduce that by 1. 1, 5 would be what comes before. If you're comfortable with that, that's great. You don't have to do anything different. But if that's a challenge, want to know what comes before, well, I'll just subtract 1. Okay, I'd like to subtract. Well, I can't do 0 minus 1, so I'm going to have to borrow from here. That gets bigger by 6. Now I can subtract 6 minus 1. 1 minus 0, and I found out what comes before. So if what comes after is hard, just add 1. If what comes before is hard, just subtract 1. Those will work for you to get to the correct number. Last thing I want to say is on page 56, number 31, that trial and error is a perfectly reasonable approach there. You'll know what I mean by that when you try it. We have both some problems in the book and worksheet, a little bit of that worksheet from last time. That's everything I wanted to talk about today as far as what comes after, what comes before, adding in other number bases, subtracting in other number bases. If anybody has questions, we've got time for those. Otherwise, just remember 2 things due on Sunday: self-evaluation quiz and quiz 5 that covers what we talked about this week. What we talked about this week is probably new and different, maybe a little bit uncomfortable at first, but the more you do it, the easier it gets. A lot of the polls went really well today, so I was pleased with that. And I'm hopeful that the quiz will go really well also. Like I said, if anybody has questions, now's a great time. Otherwise, have a fantastic weekend. I'll see everybody on Monday. You bet, Katrina. Sure thing, Austin. Bye, Will. Bye, Madison. You too, Sergio. Yeah, sure thing, Laura. You bet. Do you want 3 digits or 2 digits? You got it. All right. So how about let's have 4, 2, 1. And I don't think we did any base 9. Let's do base 9 minus 1, 6, 5. So there we go. We'll do 4, 2, 1 base 9 minus 1, 6, 5 base 9. As I go through it, you let me know if you see anything that doesn't make sense to you. So I'd like to start in the ones place. 1 minus 5 I can't do, so I'm going to have to borrow. I'm going to borrow from this column, which means it's going to get reduced by 1. And because I'm base 9, I'm going to borrow 9, which means this 1 right here is going to get bigger by 9 and become 10. It's okay for me to put a 10 right there. I'm just keeping track of these as I work through the problem. I'll do 10 minus 5. Okay, that's fine. I'll get a 5 down here. Now I'd like to move over, and I'd like to subtract in the next column over, and that's 1 minus 6. Well, I can't do 1 minus 6, so I'm going to have to borrow again. This is going to go down by 1, and because I'm working in a base 9 system, I'm going to borrow 9. So this is going to get bigger by 9 and become a 10. 10 minus 6 I can do, that's 4. 3 minus 1 I can do, that's 2. And I end up with 2, 4, 5 base 9. And the colors don't mean anything down there. The first time I borrowed, I did red. The second time I borrowed was purple, but it's just 2, 4, 5 base 9. Hopefully that